So the Tesla bot made big waves at the Tesla shareholder meeting when Elon showed a video of the latest capabilities of the bot. So I brought back Dr. Scott Walter. He's co-founded 2 robotics companies in the past, and I wanted to give us an idea of the various use cases and what are capabilities and where would it actually be used first. Welcome, Scott. Thank you again for joining me.
It's nice to be back, Herbert.
I always love it when you're here, Scott. We always learn something new. Every time I've had you here, we've now had, I think, 3 videos together, 2 on the bot, and they have just both taken off like crazy. Your knowledge about what the Tesla bot can do is something that people are really liking. So we're going to take it one step further. Before we do that, why don't we kind of give folks who hasn't seen kind of the history, let's give them a little bit of a catch them up
Sure.
on what has happened
Sure.
before we get to what do we think the bot's going to be used for and who's going to be buying it and what kind of use cases, okay? So why don't we start with this first? I'm going to go ahead and play a little clip. You can talk to it, but it's a short clip showing the various kind of the way the bot used to look like in the past. So let's see this.
Or that's actually from Investor Day. That's from February. So these are examples of potential applications that we're going to see Optimus in. Because when Optimus was announced, and I want to ask you a question first, Herbert. August 19th, 2001. What was that? Not 2001, 2021. August 19th, 2021.
Probably the mannequin when he first announced that.
That was
AI Day?
Exactly. That was AI Day 1. And how long ago was that? Because we're in 2023 right now, and we're not quite in the month of August. So
yeah, it's like a year and a half.
2 years.
Yeah.
So in case anyone's been living in a cave the past 2 years, they may not be quite aware of what's going on. And so first we had the announcement that they were going to start working on the development. And then basically about a little over a year ago, they started the development and gave us the first glimpse of it in October, and then a couple more in February and now. So we had to make some speculations like, oh, humanoid robots, that sounds really science fiction. Can it be done? And what are the use cases? Is it practical at all? And when I first saw it, and the first announcement was a PowerPoint slide kind of showing the number of actuators that are on there. And I knew right away this was not going to be the Android robot everyone imagines. It's able to go in and do absolutely everything. But it seemed like it had enough functionality to be able to start doing useful work in the factory. So as I've said in the past, everyone's expecting it's going to come in and be able to clean the house and wash the dishes and fold the laundry, stuff like that. It's like, it probably doesn't have the dexterity to do that yet, but it doesn't mean it won't be useful. And as we can see later on, when the actual bot came out, it's very different than the original one. And so we can see it's like, maybe a little bit cruder, but the functionality is still there and we've been able to see it. And so I knew right away, even before it came out in AI Day 2, that there were some potential applications in the factory, what we like to call the low-hanging fruit, very simple kind of things. And in August of last year, I put together a little animation that's called Feeding the Cookies at the Robot Zoo, showing the kind of applications that are on the shop floor that humans are doing it already. And it's so simple. It's like, it was very clear to me that the bot could do it. And we know there are going to be others. So we got very low-hanging fruit, and we have others that are going up there. And then sure enough, 2 months later, what does Elon say? He says, what are they going to do? And he said, we're going to start Optimus with very simple tasks in the factory, loading a part into one of our more conventional robot cells that welds the body together. So it's exactly what that little animation is. And then later we get that glimpse. So there it is. So there's an example of that could be a human, or that could be Optimus just picking up very simple parts, bringing them in, dropping them off where they need to be. You don't need high precision because you drop it in there. It kind of fits in exactly the way it's supposed to. You make sure you get the right number of parts. You put them in the correct order. You walk away, you hit a button, and then the traditional robots do the welding task, exactly like Elon sort of outlined right there. And then I think the same time, just before Investor Day, there was a video that came out of Shanghai, China, showing what it looks like in there. And sure enough, you can see an actual operator doing something very similar to that. And you can see that's very simple. It would not be hard to do. And so
let me go ahead and play that, and you talk to it while we're playing it.
Exactly.
Okay, let's go
exactly. So in this case, we have one operator whose task is actually to load small parts, very small pieces of sheet metal that have come out of the stamping presses that are part of the underbody. He has to wait when it's right. He gets the indication, picks up like a left hand and a right hand side, brings it on over, drops it into a fixture where it will just kind of fall right down in the correct place, And now the yellow robot can go over and pick it up and actually put it into its final destination. We see the same things happening here. And he was a bit trigger happy there. He walked in too quick. He ended up triggering a safety that stopped it. But now he's going to go in and put two larger pieces of sheet metal in there that are very light and very easy to manipulate. And you see, really not a hard task. It's something you can train someone in a matter of minutes. You can hire a person, go in there. You probably have to spend more time teaching them all the safety protocols, being in a factory and everything else, than that actual application right there. So we can see that's the kind of low-hanging fruit we know it can do. Now, do you know what question I'm asked quite a bit? Or let's say, let me tell you the question that I'm asked quite a bit is like, oh, so how much is the bot worth? What would you pay for the bot? And you don't have to answer that, right? But I've been asked that question many times, and I had to kind of sit there, like, oh, I think it's going to be a certain figure. And then other people do the same thing, and it seems like we're just pulling a number out of thin air. So it's like, all right, it's time to stop pulling a number out of thin air. And let's really look in what the value of the bot is, because there has been two things that have come up. The first question is when a lot of people said, how much do you think it will cost to manufacture? And what will the sale price be? How much will Tesla sell it for? And I'm like, they're not going to sell them. They're going to lease them. That's always been my position. And a lot of people who thought they were going to sell will go, oh, yeah, of course they're going to lease it. So there hasn't really been much discussion there, unfortunately, except for Yaman. Yaman's like the first one to say, oh, there's too much consensus out here. I have to take the devil's advocate role, and let's talk about that and whether it makes sense to actually sell them lease. So we can go back and forth. What's the better model? I think leasing in the beginning, because it gives them control. It makes sure that it only goes to the right people. And if they're misusing it, they can bring it back. They can get all the information. And it just seems like it's such a moneymaker. It almost makes more sense. And I don't know what your thoughts on there. What would you, if you were Tesla, would you sell or would you lease?
Well, I think what we've been talking about, and it makes most sense, is that for the first
Mhm.
several years, they do not need to sell this bot to any
Yes.
other vendor because Tesla has 130,000 employees today, multiple factories. Well, we just showed a video clip there of Tesla China, Giga Shanghai, and we saw a bunch of workers doing manual work, moving things around. And so there's probably, like you're saying, the cost savings, which will walk me through that shortly.
Exactly.
But I don't think they need to sell to anybody for many years. They themselves, and then the next thing after them, I
Yeah.
would imagine, would be their subcontractors, vendors who are building products that they need for feeding their cars.
Yes.
And so they, even just themselves, they could probably use 10,000 bots before they decide to release this to the wild. But yeah,
Exactly. And when they release it to the wild, then the question at that point, is it going to be leasing or is it going to be that they actually sell it? And to their suppliers, they might have like a really interesting arrangement. It's more of an internal use through the supplier. It's not even a lease sale. It's like you've got to use it as part of the production process if you want to supply us parts. But if at some point it's going to go outside, and we just don't know, and we don't know how much they're going to charge, except that Elon has says it will be cheaper than buying a car. And so a lot of people think it's probably somewhere around $10,000 and $20,000, and that something you would be able to. He said something you'd be able to afford for your parent or something like that.
I think it depends on the margins and the price. So let's say that it
Hmm.
costs Tesla $20,000 to make this bot. But what is the margins they're going to get out of this? And I think I've heard
Exactly.
some people, you say $10,000 to build.
Yeah, yeah. We think they'll probably get down to 10,000 pretty quick, and then over time they'll be able to scale it down way more, like 5,000. And the question is, how do you account for what it actually costs? Because you've got to look for all the R&D and development costs. But if you kind of strip that out, I think right away they could start building it for probably easily $10,000 when you look
So
at
with the
the
cost of goods
material and the labor cost. Yep. Hmm.
being only $10,000, this gets you so close to just doing a
Right.
leasing model
Right.
or some sort of, don't even charge you for the hardware, but we'll charge you for the service on a monthly basis and just shoot it
Mhm.
that. Well, I mean, this is a forever thing. Once you've got bots, you want to maintain it, you want to swap them out. You'll probably want to
Yes.
swap, like it scuffs one arm, just quick swap. And so why would you buy that bot? I own that bot. No, I buy the service of a bot and they're just going to keep swapping it as it improves, as it goes. So I would think that they'll quickly switch to a subscription model, but don't know. I do not know. So
Yeah. And that's clearly going to be in like the B2B situation, that when they're doing it from one business to another. But when it actually goes directly to consumer, whether it's still going to be leasing model, I mean, that's just, we don't know. But we do know from the standpoint is that there are two types of robot manufacturers that are in the humanoid space. Those that are making it and they need external customers because they need to actually sell it. And so they're going to come up with their own way of getting that cash flow that they're going to need. And then there's Tesla that has the built-in use case and they don't have the urgency to sell. They do not need to sell the bot in order for it to make financial sense. So that's the model we're going to start looking at right now, is how much does it actually save Tesla internally? And from there, we can start to see that, well, then if you were not Tesla and you had access to a bot like this, what would it be worth to you? What would be your valuation? And if we want, we could sort of start to have fun with that spreadsheet. I don't know if spreadsheets are fun, but we'll bring it up and get an idea of what's going on. And I'll tell you my sort of assumptions behind it. Because again,
Sure.
people wanted me to give them a number. And I'm like, okay, it has to be more than an educated guess. We really have to go ahead and put together a model.
But before we go look at the spreadsheet, which I'll bring up right away, I think you made a very, very good point that I would just hammer home. That because it's Tesla, they already have existing factories. They already have the existing employees. They already are building cars and many different products. So this robot division isn't the standalone company that needs to be funded. It's sort of kind of like a program that they're doing within this massive company. So they don't have a lot of expenses, right? They just write off all the executive R&D, all that work, all that stuff to get a company going. Other companies, they're purely a bot company. They're spending so much money building this thing. They need to sell it right away to get the revenue. This is kind of a
Yes.
nice to have. And so for Tesla, they don't need to sell this. They can take their time. It's incremental cost for them as they build this. So I think that's a very good
Yes.
point. Okay, let's take a look at the spreadsheet. Yeah, walk me through this.
Okay. So we got the spreadsheet, and hopefully I gave you editing capability this time. All right. What I've done in the top table is I kind of, within the factory, you're going to have people with different skill levels. And so I just came up with like 4 skill levels, 1 through 4 for now. And from what I understand, I believe the lowest starting salary in a Tesla factory is probably around $25 an hour. So it's more than minimum wage, but that's the minimum wage within the factory. And you have to remember that that might be what the worker sees as what they're getting each hour, but then you have to put FICA taxes on top of it. And then traditionally there's like an overhead. That's,
Mhm.
the fact that you're not just paying them, but the space that they're in, you've got to have break rooms, you've got to have all sorts of other services. There might be benefits, everything else. 25% is conservative. I've heard a lot of people say it might be more like 35% or something like that. So we'll keep it conservative right now. There's the FICA, there's the overhead, and you're working 40 hours, one shift, 52 weeks out of the year. That
Mhm.
means someone at skill level 1 is almost $70,000 in direct costs that you have for having that person working on the floor. And then you can see skill level 2, if you go to $30, $40, $50, how much they roughly cost. And then I put
Mhm.
down like an annual cost for the bot. So this is not to buy the bot. This is like, if you had the bot, maybe for some reason there's going to be about $10,000 worth of cost of electrical usage, of maintenance, of moving it around. And this is not necessarily the cost of having someone teaching the bot or managing or supervising the bot in any way. So we'll just say, okay, that's like
Mhm.
some additional cost that's going to be there. Now, so if you're only running one shift, that's sort of what that skill level costs. But let's say we go to 3 shifts, either 2 or 3 shifts. So if we go and change that, then we'll see that skill level. If you're able to then with one bot do the 3 shifts, you'll see, well, how much does that now start to cost you?
Yeah. I don't think you gave
And
me editing.
I should have given you editing capability. So we can play with a lot of things here. One of them is, if are they just 40 hours a week? If there's overtime, then obviously the cost is going to go up. So if you typically have like 5 hours of overtime each week, that means the cost of that worker is going to be a little bit more. But again, we'll keep it conservative. We won't put the overtime in. You can always play with this to make it worse. But if you go to the 3 shifts, you'll end up seeing how much getting that particular operation per year costs you. So now at the very simplest skill level within the factory, it's costing you almost $210,000 for that one
Mhm.
particular operation that's going on. Okay, so now it starts to get a little bit interesting. So we go down to the lower part there. We say, okay, how many stations are there on the floor where you might have like a skill level of 1? And so you get a skill level 1, and let's say, that operation typically requires 1 human to do, but the bot's kind of slow. It's not able to, so we're going to need 2 bots there to do
Hmm.
the same thing for some reason. Now, the bots just cannot operate on their own. They have to be supervised. So that means, how many bots are kind of in a group, which means within the group, you're going to have that supervisor, and that supervisor has a salary. And I'm assuming the supervisor is going to have like a skill level 4 salary. $50 an hour is what it's going to be. So it'll be a little bit more. So you're going to have kind of these ratios in there. And so over in the manual column, that's how much doing that operation is going to cost you with the 3 shifts per year. So it's going to be about $100 million, a little over $100 million to maintain those 500 stations. If you do it with a bot, this is how much the bot's going to cost. And part of, a lot of that is sort of the salary of the supervisor of the bots, because, for some reason, it's a very small group. Obviously, if you increase that number a lot, then suddenly it changes. So you see there's a savings about $50 million. So almost a 50% savings doing that, even though you would still have to have a supervisor. And of course, already on the shop floor, you have foremen, you have other managers that are supervising them. And I could be absolutely wrong there. It's like, well, that person is already doing it and they can just do it for the bot. So it's going to be a 1-to-1. So you can almost take it out. So again, I'm trying to be as conservative as possible here. And then you say, well, then there's skill level 2, maybe there's 1,000 of them out there. And then maybe 500 skill level 3, and at skill level 4, maybe there's 100. So you can play with these numbers to sort of get an idea of what are the savings and how they go up and how much you could potentially save in 1 year. So that's just a year of operation by having the bot. So about $350 million, and that might be just within one factory. And then we've got 4 gigafactories. Oh, yeah, we have like 4 gigafactories running right now, and a 5th one that'll be coming on there. So you can see pretty quickly, even with that conservative numbers there, you're looking at Tesla's able to save maybe $1 billion or more a year. Now, I don't know how much the bot research is and everything else that's going on there, and maybe they kind of cancel each other out. But with a very conservative case, you can always say they're not going to be losing money. It's not going to be a drain on resources, and they may be saving a little bit. But as you start to replace some of the higher skill levels, as you can see, then it's going to go up a bit more. And if one person can supervise maybe 20 or 30 bots in that group, then it gets a lot better. So the reason why the bots cost so much, it wasn't because the bots cost so much, it's because you needed that supervisor. And you take that out, and then suddenly the bots don't cost a whole lot, and the laborers do cost quite a bit. So I think if you went back to the sheet, you'd see how much it actually cost in total for the labor for about 2,000 workers, or let's say, to maintain 2,000 stations, 2,000 operations going on somewhere within the factory that was going on. Did I not total the whole thing up? But I think, we can see individually 100 million, 250 million, as you add that on to 300. So yeah, the salaries get pretty high after a while, the labor costs.
Mm-hmm.
So that is one example. And now if you were running your own factory and you were thinking of how can I reduce my cost by 50%, then it seems like, well, Optimus would make sense to do that. And now we could talk about what's the best business model for being able to get that in to one of those other factories. Is it to lease or to sell?
Okay, so when you did this calculation, this spreadsheet, are you
Mhm.
thinking that this is something that they can do with the bot capabilities today, or is it like 5 years from now when it's got to be a
Yes.
certain skill level before it gets there? What were you thinking? What's your
What
assumption
I'm
there?
thinking is we look at the video that came from Shanghai, and it's very clear the bot will be able to do that by the end of the year. So I'm
Okay.
pretty sure they've already done tests and examples and proof that the current version of the bot can do it, and it's going through an iteration. So what we saw at the shareholder day is they had gone from having some pretty good mechanics that they were hard coding what it was going to do, and it was pretty clear it would be able to do that, to now they're coming up with a new method of teaching it. So they're really re-architecting the way the software is going to work in conjunction with the hardware. So they're pretty confident that it can do those tasks, probably skill levels 1 and 2, maybe eventually getting up to 3 and 4. But 1 and 2, they are probably able to do that today. It's just a matter of coming up with a really good way of teaching it. So it's very simple to show it a new operation here and there without it taking weeks and weeks of effort to do it. So again, here's an example that they want to go through just demonstrating what the function is, and then the bot will do it. It will just repeat it, because that's exactly the way it works in the shop floor today. A manager comes in, shows a new hire, this is what you do. You grab this part over here, you put it in here, you drop it over there. Okay, can you do it? And then sure enough, they repeat it and they go. So you want to make sure it's very easy to teach that to the bot. And that's probably what's going to be perfected, let's say, over the summer. And then by the end of the year, they should be ready to start putting it into some cells here and there that actually will be kind of getting its paycheck, So
A
it'll get
lot
its
of
first pay
people,
stub.
a lot of people have not believing it. They're not thinking this way. They're thinking
Mhm,
that the bot is great. It's a nice toy. It's going to take you years. It's going to be a long time before we should even think about it coming out to work or be sold in production. What you just
mhm,
said today is that it's going to be able to replace some workers already, if they wanted to, in the Tesla factories by the end of this year. And that video that we showed of the workers in China, Giga Shanghai, where the worker was grabbing pieces and moving it and putting it
mhm.
to a certain area, and it continues to do that left and right. That's stuff you're saying the from the video we just saw now of the Tesla bots capabilities last week, that by the end of this year they should be able to do just that. For example, that task.
Absolutely, absolutely. And a lot of tasks very similar to that. And there's going to be a lot. And they're going to do it without having to reorganize anything in the factory. It's just, oh, okay, we're just going to come over here and have the bot do it. And we'll run it for a bit to make sure we're confident that it's safe, that it's not breaking down this thing. And then they'll start to deploy it more and more, and they'll start to grow. And I've discussed in the past that once you have it there, the way you design your factory may end up being a little bit different, because there'll be some operations it could kind of do that the human can't, just because of safety reasons. And it will be very
Mm.
coordinated and will never get tired and never make a mistake. So it doesn't have to worry about doing something that might be considered quasi dangerous. And but you're not going to do that
Uh,
with the existing factories. You're going to do it if you're
Yeah.
building out new lines or new factory like Giga Mexico, and the unboxing process, and it's there. So what I'm seeing is that their end goal is that we're going to be doing it in Mexico. We're going to be having a lot of the bots there. That's our end goal. But before we get there, we have to be
Mm.
able to perfect it and prove it out in these scenarios. And maybe it grows a little bit more and more in Texas and in Fremont, and then eventually, probably over Berlin. But the end goal is to make sure they are working really well when they are ready to start the ramp up in Mexico.
Okay. Let me play a couple clips just to explain what I think you just said, right? Which is,
Hmm.
this is Giga Shanghai. This exists today. There's a
Video.
video of what's happening there. You
Oh,
can see
what
this
that
big,
worker is doing right there. Yeah,
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 just this
you can
worker
do
is doing
that.
right here. It can be done by a bot right now. So these are large, giant bots that are moving, but you see that there's a cage. This person is protected from these large bots so that he doesn't get hurt, doesn't move. He's moving around, moving things around. That's a worker. This is another worker. As you go down this list, we're going to see lots of workers. But you see how the bots are inside cages. That's what you're
Yes,
talking about. That protects the
yes,
human.
yes.
Now you're
Yeah.
saying
Let's say
this
the
video,
industrial robots. So we
the
don't want to
industrial
confuse it
robots.
with Optimus, right? So
Yeah.
basically, it's the orange ones, which are the industrial robots, and that's what Elon referred to as, the traditional robots. So the belonging
Yeah.
parts into one of our more conventional robot cells. So that's a conventional robot cell, and there you
Yeah.
are
And what you're
loading the
saying,
parts into it. Hmm.
yeah, that if that's because you need to protect the human. But if you have a
Yes.
Tesla bot, you don't need to have these cages, and you don't
Hmm.
even need to do what this person's doing, where you walk into this area, moving into the caged area. You can actually have this all inside that same spot. And I think you called it a choreography. If the bot
Yes.
knows how these arms are moving, and it's not as we don't. I mean, yes, it's going to cost you $20,000 if they get hurt, but it's not like a human life. And so you're going to have them all programmed so they can really just never hit each other, just like these bots. They don't hit each other. And you don't need to have
Yes.
these cages. And that's how that works. Okay.
Yes. Yes. And so your factory floor you can get more utilization out of a smaller area.
Mm.
And that will
Okay.
be important to the unboxing process. And ironically, what was going on in the Shanghai video is the workers were actually feeding parts to another robot that was picking it up and then feeding it to the others. So it seemed like there was this middleman robot. Well, can we get rid of the middleman there? So ironically, what may happen is Optimus may also take away the jobs of some of the conventional robots in some situations, because it will be able to perform that task
Mm.
also just as well. Not the big ones, not the real specialty things like, the welding, the painting robots, those are going to remain the way they are. But where the humanoid form factor is needed to make the interface between the movement of the parts that are coming in on the pallets, in these different boxes, and you need to make sure you have a humanoid form to do that, and that's where Optimus comes in.
Wow. I'm just going to quickly show some parts of this video because it was funny. The last time we did this, you kept saying, see that
Mhm.
job, see that job.
Yes, 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 yes.
Like that job back there, that person back there grabbing
Right.
things,
What's going
moving
on
it.
right behind there? Exactly, exactly. So it's another example, because there's so much sheet metal and pieces that have to be put together to build the car. And that's just in that one section of the factory. There's going to be other areas that the same kind of things are going on. There's going to be loading of tires onto into conveyor belts that are going to be going on out to then get mated onto the cars. So there's
What
all
about
these
this
very
guy?
simple operations that you see today. Exactly. Yes.
What about this guy?
Yeah.
He's driving
Yeah.
this thing, probably.
Yeah. And that they're looking at having, more mobile robots being able to move things like that around already. But again, at some point, something has to be taken off that mobile robot and brought over to the conventional robots. And
Yeah.
so that form factor is going to come in. And again, you can see they're very simple tasks that would be very easy to automate with the humanoid form robot. And the question that always comes up is, well, if it's so easy, why didn't they just do it with the traditional robots? It's like, because it's not quite as easy as it seems like. There's some things that
What
are
about
better suited to the
yeah?
humanoid form.
What about this one? So the car is on a line, it's moving along.
Hmm.
So now at this
Hmm.
point, you can't have those industrial robots as much because
Correct.
it's smaller parts.
This was
Here's
that's
why,
what I was
right?
talking about. Yes, and I saw that in Texas. That example, I hadn't seen this in this video before. That's very easy. See, they're just unstacking tires and putting on a conveyor. How hard can
Uh huh.
that be? And you don't need superhuman strength there, because you have those units there, which are the lift
Yeah.
assist to do that. So it's very easy to go over. You just squeeze a button, it grabs it, you come over, you just drop it anywhere in the conveyor. So you see, there's absolutely no precision needed there. But you've got two workers that have to unload that. That's something that's very easy to do with a bot.
Okay. So that brings us to this, which is
Hmm.
hold on, where is it now? So this brings us to this, which is this is the reason why they are making humanoid robots,
Yes.
because that example where that bot was grabbing this, what did you call that? A lift assist?
It's a lift assist, yes.
It's designed for humans to use the lift assist because it's going to be able to carry very, very heavy objects. But you need to have hands. The way that he grabbed it was through hands. And so now you don't need to change those out.
Right.
You just have the robot that is designed just like a
Hmm.
human. You want to speak a little bit to the capabilities of the hands? Um,
Yeah. So what's going on there with that lift assist, and with any other kind of piece of equipment, the lift assist is almost like bicycle handles.
yeah.
And you pick it up and you put it around, and then you have what looks like a bicycle brake that you have to squeeze when you go down there in order for it to engage and make sure, okay, it's going to work, and then lift it up. So that's designed already for the human form factor and the hands. And we have, all sorts of tools that are designed to be grasped with the human hand. So you want to come up with a mechanism or some sort of automation that uses a human style hand to go in and do the human operation. That way there can be this nice one-to-one swap out. And what had happened in the past is that humans were able to do a lot of those operations with tools designed for humans. And then the robots came in and they redesigned the robots. The robots do not have a hand like this. They basically just have an end that a socket that you pretty much just mate some robotic end of arm tooling on there. And now you have a spot welding robot, or you have a painting robot, and it's there and it's kind of permanent and it's very hard to remove it. It just can't go over and grab another one and put it on there. And that tooling was so special that a human can't just pick up that tooling and use it themselves. It's just designed for the robot. So once the cells were automated, they remain automated, and there's no way it's like, oh, if the robot's down, a human can go in and do the task. The idea of Optimus is to be completely swappable in both directions. So Optimus can go in and start doing tasks that have already been designed for people, right out of the box, no changes. And then if for some reason we're having some problems with Optimus, is not performing that well that day, or it happens to break, then it doesn't matter. A human can go right in there and start to take over immediately. So they're completely swappable. And you can see all sorts of reasons for that. It may be that you have a lot of operations in line. You're not really, maybe you have a labor shortage, or some people are sick, or they just need a break. So the bot goes in, works there for maybe 20 minutes or 30 minutes, and then goes back out, and the human can go back in. And that will allow you also to get more production during the day, because a lot of times the factory slows down or has to stop for fixed periods of time because everyone's on break. So, okay, so what we're going to do is we're going to make sure that we don't really have everyone going on break. We've got the bots going in and taking over when they're on a break.
What's your estimate? So you've said that you made the statement that you said that even by the end of this year, you believe that the Tesla bot's capabilities, as it was shown last week, can already be used in the factory. In one of our videos, you predicted this even before you saw this video last week. You already said that it's very likely that the very first Tesla cars has already been worked on by the bots. But what percentage of jobs in a Tesla factory can be replaced by bots? And specifically, like right away, like, do you think that there could be 1,000 bots being used by the beginning of next year, for example?
It would be possible, yes. So long term, should be able to do almost all the tasks in there. So I'm pretty sure long term, just about everything, and not just in the factory, also outside the factory, in our home, and everything else. That's the long term goal. Right now, it's going to be the low hanging fruit to see how that goes. And it may be in the case that the bot is not quite as efficient as a human. That's why I put in my spreadsheet, you might need 2 bots to do the same task. So when we saw the Shanghai video, we saw there was one operator that was actually loading 2 stations. But it might be that when you put Optimus in there, it can't walk quite fast enough. So we now actually need 2 that are kind of dedicated to there. So we may see situations like that, but in the end, it will be able to perform well enough to justify it being there to cover those costs. In many cases, I think there's going to be cases of attrition that will be how you start swapping it out. So you're going to have a lot of bots. The bots are going to have maintenance issues at the beginning. They're going to have some training issues. You're going to have things just breaking down or not quite functioning the way that you expect. And so there'll be a little bit of ramp up on there. So that's why I'm thinking that, 500 to 1,000 by the end of the year going in, and then maybe not replacing 1,000 workers, but going in and taking over the task of maybe 100 or 200 workers here or there.
Okay. That's by the end of this year. So what is your projection of what's going to happen from now to, let's say, next year? So some people are saying
the best projection is to listen to what Tom Zhu said. He's talking about that for Giga Mexico, that there would be 10,000 workers, and that maybe 5,000 of those would be humans, and 5,000 might actually be Optimus.
What? He said this?
He said that. He said that. Yeah, he said that at the Investor Day. Yes, Investor Day. When, it was there. When he came out and did the presentation and they revealed Giga Mexico, he says, what does it take to build a Gigafactory, and the number of workers? And he sort of said that, and it may have been that he just an off-the-cuff remark or a prepared remark. It's hard to say, but it was sort of that, it might be a mix of 5,000. So we know that's sort of what they're looking at. And again, they're designing the unboxing process to make sure it's going to work for Optimus. They're actually going to probably simplify it enough to make sure Optimus can do it. And if Optimus can do it, well, we know a human can do it. But right now, we know there are jobs that humans can do that Optimus cannot do yet. And it comes down to 2 things. One, the dexterity is not there yet. So the fingers do not have the fine motor skills to be able to do that. But they're good enough for a lot of kind of tasks. Like we saw, just being able to pick up a piece of sheet metal, drop it off, does not require fine motor skills or anything like that, or even fine placement skills at all. And Elon has always said, basically repetitive, boring, dangerous kind of jobs. And a lot of those we're seeing are definitely repetitive and boring. So look for the repetitive, boring jobs. Those are the ones that are going to be replaced first. And then, of course, if there are some that are dangerous, but most of the dangerous jobs in a factory already are being done by the industrial robots. So in the past, I don't know if you've ever seen a stamping plant. So, we see these big presses that come down and take the sheet metal and then deform it,
Mhm.
and it comes out looking like a hood. Well, it usually takes multiple steps to be able to do that. So sometimes you might have three dies or three presses, three stage presses, or like six or seven. So the sheet metal constantly has to move from one place to another, one place to another. Well, before they had that automated, there were workers that just grabbed the sheet metal and moved it over to the next press, grabbed it, moved it, and they had to do that, every 45 seconds, and they had to wait for the press to go down. And that was just something all day. And of course, they had to have these big earphones on, earplugs, because it was just so loud. And the whole day, these presses come down, boom, boom, just
Mhm.
that. That was their job. I mean, you look at that, and say, oh my God, I might be able to last one day doing that, but I cannot imagine that's something people are doing quite a bit. Well, that's been replaced with automation and robotics for that reason, because it was dangerous. People occasionally would get tired, and when that press comes out, you can't stop it. I mean, it just goes. It just goes and goes and goes, and it was very difficult to stop that. So that was like one of the first places we don't really want people there. So if there's
Nice.
any of those left in the factory, you would see Optimus going there.
Yeah. And you're an expert in this space because your two robotics companies were specifically those industrial robots inside a factory, and you planned
Hmm.
out how it is installed and how it works. Um,
Yes.
then you just said Tom Jew said 5,000 out of 10,000 employees, 5,000 of that would be bots. That's shocking to me. So some people are saying though that it might this idea that they're going to create 1,000 bots by the end of this year. They need that because they need they need as much information to be able to teach and learn the surroundings. You need 1,000, not just tens or twenties.
Hmm.
But some people are saying, this is the first version. They need to have multiple versions before they're going to go and spend the time and effort to build 1,000 of them. So what's your thinking about that? Like how knowing Tesla, knowing what they can do here, do you think that it'll take 2 years before they'll get to 1,000? I know you said your guess is 500 by the end of this year is what you've been saying,
Hmm.
but to actually do the jobs like you're saying that they're actually doing it now because the fastest way to learn is to put them in some job and then
Put them in
learn
there.
from that,
Right.
right? So
Right. And
let
the
me just show
question.
something.
Yep.
Yeah, you shared this photo a long time ago to me because you were saying this
Yes.
is something they shared before shareholders day. This was investors day several months ago, and you're
Or
saying
yeah, AI day two. Yep.
AI day two. You're saying, wait, when was AI day two? Last year?
September 30th, 2022. Yep.
Oh my God. So you're saying it's September 30th, 2022. They already had this vision of this bot, which looks very similar to what it is now. And you're
Which was
saying that
probably
very
already doing
likely
it in
this wasn't,
August.
yeah, this wasn't just a marketing stint. This is an actual bot trying to do some work so that they can learn everything. Whether and you pointed out that they
Yes.
needed to fix the hands because it couldn't really quite grab that as well.
Yeah.
That
Yeah. It
what
looked
you're
like
thinking?
they added a degree of freedom. Hmm. So it's not a laboratory setting. That's definitely a factory setting. You can go down, that's on the shop floor. And they have some sort of machine there, which is probably drilling holes or doing other things into those aluminum bars. And they typically come out, and an operator would have to sit there and do machine unloading. So it's just picking up and putting in the tray. It's picking it up and putting in the tray. So that's what an operator is doing. So they said, oh, that looks like real low hanging fruit. Let's see if the bot can do that. And you could see the bot did that. Now, if that piece that got picked up from there, they got put in that red tray, ended up in a vehicle somewhere, okay. So what I'm saying is that it's already performed a task on the shop floor. It may not be that it's doing it every day, and it may be that they tested it out and said, okay, let's go back to the lab and work on it a little bit more. We've learned some issues there, and it
Yeah.
may not have done it like super fast, but that was like kind of a non-critical area that you're not working on the assembly line. That if you're too slow, you're bringing the whole thing down. It's completely separated from everything else. We're just trying to stack these things up. So if any of those pieces of metal that Optimus picked up and put in that tray ended up in a vehicle, then it's like Optimus did that. So we know it's already demonstrated that it can perform a task on the shop floor that actually can add value to the car and get that process done. The question is how many more of those that it has done. I think it's done quite a bit. Whether it's done it continuously, that's probably an open question. I don't, because we probably would have heard leaks or rumors of like that. Yeah, Optimus did like 3 shifts last week, or did like the whole week just absolutely nonstop. You may have heard of that. I don't think they're quite there yet, because you're right. They're trying to perfect the design before they scale it up. And we
Mhm.
know there's at least five because we saw a picture of at least five.
Mhm.
I suspect there's more. There's probably in the order of a dozen or more to have all the different groups to be able to work with it, to see how it's performing. And they probably have it to that they're 95% happy with what they've got and are
Mm.
tweaking a few things before they say, let's do it. And there may be some components that they're already scaling up. So for instance, maybe the servos in the hands, they might be saying, those are exactly what we need. Start ramping because we need to have 6 of them for each hand. It means we need 12 for each bot. So that might be sort of what would limit us from being able to put out 500 or 1,000 by the end of the year. So maybe let's start figuring out how to scale up that production into it. And maybe they're looking
I
to going to
yeah.
castings on some pieces here and there. And others are like, oh, hold off on that. We haven't quite completed the design. So they could be looking at it that way.
And then if you take what they said, which is what they've learned, is when they're designing something, they're actually looking at manufacturability before they actually design it. In the case of Cybertruck, it
Yes.
was manufacturability that led to the design, and so they probably have already figured out if I'm going to create these bot parts, how am I going to do it? It's probably the
Yes.
unboxing process. Here's the hands, here's the arms, here's the legs, here's the torso, and at the very last minute, Lego set, click.
Right, right. And when I was taking classes in engineering, they were starting to talk about design for manufacturing. And no one quite knew what that meant. For the most part, it just meant don't come up with a part that we know is like impossible to build. There's like physically no way to do it. You know, the idea that you would have something built inside of a sphere, that, you know, how do you get it in there? It's like, well, that's crazy. The sphere has a seam. You have to be able to take it apart to be able to put whatever that thing has to go in there. So we know you have to, so that was considered impossible. Don't design something like that. But it wasn't like they were really teaching how to design the part to be easy to manufacture. It's just like make sure the thing could be built. Now, of course, that example I just gave you, someone is probably jumping, you know, right down in the comments right now. It's like, of course you can do this. It's called 3D printing. And it's like, yeah, but you know, back in those days, it didn't exist. So what is possible today, it keeps changing. It's a moving target. You have to understand it. But at the same time, you have to make sure you're thinking about how things are going to come together more easily. And it's more or less when if you were designing a human being from scratch, you probably wouldn't put the navel in there. You say you don't need the navel, it's not needed. But obviously it was sort of needed for us to be manufactured and built. And so the same thing happens in the cars and
Mhm.
the car bodies is that on the sheet metal, there'll all be these tabs that have absolutely no function whatsoever to the car when it's driving down the road or doing anything. But it's purely there to make sure that when they line it up, everything snaps into place like it's supposed to. So it's easy to manufacture. And that's the difference, the mindset you had to have is start thinking about the things you put in the product are going to make it easy for the pieces to snap together and not just say, this is my door. And you manufacturing engineers just figure out how to build it whatever way you want, but I'm not going to make it easy for you. It's like, no, go back to design, start thinking about that, make things easier and easier. And Tesla has always had that mindset. And they've done that by making sure the groups talk, because in a lot of very monolithic kind of organizations, what ends up happening is you have the design group over here, the manufacturing group over here, and rarely do they ever talk. So when my design's done, I just throw it over to them. It's like, their problem. And when they come back
Mhm.
to me, I just shake my head. Yeah, your problem. And it's like, no, everyone's always in the room. It's everyone's problem. Everyone has to solve it. So you can design it great. If you can't build it, then it's a bad design.
All right, so are you being a little overly optimistic? So you are saying that there's likely going to be 500 Tesla bots by the end of this year. You're saying that
Mhm.
there's already jobs within the factory that they're probably testing it out and using it for, and then you're saying that the likelihood is they've already designed the way that they're going to manufacture this, and that you said just 10 minutes ago, you said that you believe 95% of the bot is already likely established and just tweaking it for the final five before they're going to do mass production. Uh,
Let's say
that's
mass
a pretty
production
big
of
statement.
version one, or a little bit of
Mhm.
scaling, so that they're at that point to say, okay, it makes sense to make 1,000. And James Dama has kind of pointed that out, that you need the training data, but you want to make sure when you get the training data, you're getting on something that is going to actually work. So you make sure you
Mhm.
have a smaller number at first, test it out, and if it looks like it's reasonable, you then scale it up. So you're not going to then say, let's build 10,000 of them, because you're going to learn a lot more from 1,000 bots than you are going to from that first dozen or so that you have. And what you learn there might tell you like, oh, it's a good thing we didn't go to 10,000 because there's a couple adjustments we have to do there. But I think we can all agree with full self-driving. We know if there was only 100 Teslas out there doing full self-driving, it's not going to improve. It's going to improve at a very, very slow rate. So you need to get the numbers out there. And at this point, it's making sure the mechanics are sound. And if the mechanics are sound, it's about training. And the more you have out there, the more repetition, the more they're doing this stuff, the more important it's going to be. Some of it might be very mundane. It might look like a robot kindergarten where they're just going in there and there's tables with balls and cubes and little shapes that they have to pick it up and put it in there and doing very, very simple things, probably a bit more exotic than that. And then will be the examples actually on the shop floor. And of course, the thing you got to remember is that when you put it down the shop floor, you might be impacting production. So you have to be very careful where you do it, that when you put it in there, are you doing it, making sure it's not slowing down the line at that time.
Mm-hmm. Yeah.
So maybe you do it during a third shift when they're not really running. It's like, okay, we can go in there. We'll go ahead and run it. We don't care that everything is slow. But the first thing is you want to make sure you're not impacting the bottom line. And that might be where it's a bit delicate finding some of those jobs and why they will have the Optimus there. And then the actual worker is still going to be there in case Optimus fails and goes in and keeps the line running.
Okay. I'm going to play a couple streams and I want to ask you something. So first one here, this is a human that is teaching the bot what to do. He's got VR headsets. He's got body suits. Whatever he does, the bot is able to replicate and be able to learn the environment. Okay.
Yes.
So couldn't they just put 1,000 of these, instead of creating 1,000 bots, just get 1,000 of these, give it to as many humans as possible throughout the factory, do what they're doing, just normal. And then that alone, you don't need necessarily, 1,000 bots, but it's teaching it what to do. Wait, let me continue this thought. Then I'll ask you the question. Then we watch this. This is your favorite scene of the entire video, because here, this guy, oops, you saw that. I don't know if you guys saw that. Let me play it one more time. This worker in the back, this engineer in the back, you can watch him raise his hands. He's so excited. Boom.
Yes.
Because the bot did this on its own. It saw whatever that is, a lemon. It grabbed it.
Lemon or potato.
It's yellow, man. So it grabbed, maybe because you raised potato. So he grabbed it, and then this is untethered, and it just knew where it was, how to grab it and raise it, and you raise it. That's previously because it was taught how to identify things. So let me answer that question. If you think that, can't you just put the VR headsets to a bunch of people? You don't need 1,000 bots, do you? Why do you need 1,000 bots if you can put 1,000 headsets on people?
Okay, so you've been able to do that a little bit with full self-driving in simulators. And so what that does, it gets you to a certain level, but simulations and reality are very different. So when you get out there, you start understanding how real world physics behaves and what lighting is like in the real world and everything else. So it'll be the same thing with a bot, is that we don't want the bot to have a completely blank brain when it's going out there and working. We want to make sure it has some innate capability, and then it can then start to learn from that and make the improvements. So a lot of it is that you need to have things always a little bit different every time. So it's going to go in and understand how to adapt to a slightly different situation each time and do that again and repeat and repeat and repeat. So it's a lot of cycles you need to get. So some of it they'll be able to do in simulations, but in the end, you're going to need to have the actual physical bots out there performing those tasks, because, walking is pretty hard because real world surfaces are very different than what you have in the simulation, no matter how hard you try to get the real world physics. And so it seems like it would be really good. Get out there and it's like, whoops, the motor torques are saying this is not what we were predicting, because this floor surface doesn't quite feel like you were showing me in the simulation. It's a bit slicker. It's a bit harder. There could be all kinds of things, different incline. There could be a pebble or something like that you're on that suddenly makes the foot have to deviate a little bit. So you need to get that real world experience before it will be really ready for the shop floor, and that you'd have the confidence in doing that. But going back to what that was about, is why that was so exciting, is that they've already grabbed parts before, so it was the big deal. But up until then, they more or less had to write a lot of these heuristics that would describe what the actions were that the bot was supposed to do. And now they had finally gone through to have what they call the end-to-end. So it's a neural network controlling everything. It sees the goal and it figures out how to move the hand over there and exactly what to do. And it's like, okay, what fingers do you close and how do you close and actually grab it and pick it up? And so that is when they pretty much threw out the old way that they had been teaching the bot up till this point to now this is the new way forward. And that new way forward is going to be ramping up really fast. And that's what's going to be exciting. And that is where you're going to need training data and a lot of real world training data.
Okay, you're very, very convincing. So this is very optimistic, right? We're thinking that there's going to be quite a number of bots already in place. But I think the what you said earlier, which is the thing to hammer home, is that Tesla does not need to sell this to anybody. They can just use it in their own factory. The savings that you pointed out in your spreadsheet is significant, just by replacing human workers for even just a few jobs that they can already do today. And then those savings can impact the gross margins for the creation of, the operating margin or the margins, wherever it falls under, to creating the car. And you are so optimistic that it's actually happening sooner because, let me pause for a second. I mean, about a year ago, most of the experts were saying, don't expect this bot to come out. Just like whenever they announce a product, it takes them 5 years before it really is produced,
Right.
because it's very hard to make a bot do bipedal walking. Here we are a year later seeing it happening. It's very hard to be able to grab something and know the pressure. And you've been explaining to us how that works, how a bot's fingers can know when to stop press. The difference between a water bottle and a steel bottle. But so you're seeing from the videos that the progress is so fast that you actually confident to predict what the predictions you've just said today.
Yes. And again, I keep on going back that, August 19th, 2021, that was the first. So it's not even 2 years. We've seen a lot of progress in 2 years, an awful lot. And so we're going to see a lot more because they've really laid that foundation that they are ready to start hitting that S curve. And so they know what the design is going to look like. They've got the team together. The neural networks seem to be coming together. That control system looks pretty awesome and what's able to do, the torque control. Their walking is getting better and better from where it was before. So the robot looks a bit more confident, needs to get a little bit faster, but that's all going to come. And I can clearly see that by the end of the year, they will probably have a bot that is good enough to start taking over some tasks in the factory. And probably 2024 is definitely going to be the year that you start seeing it deployed more and more within the factory and starting to save the company money in labor cost for doing these different operations. That's a little bit different than the normal plans. Everyone says, oh, it takes a long time before this product's coming out. But remember, it's like, we're not looking at it as a product. We're looking at it as a way of being able to actually save Tesla money in the manufacturing of their goods. And so that's what it is. It does not have to be perfect. And the manufacturing and scalability of this is very different than a CyberTruck. A CyberTruck is very difficult. And so that's part of the reason that those production ramps are taking a long time. And it's a completely different set of operating rules that they have to be able to get this bot to go. The biggest challenge is making it smart enough. And I said that from the beginning. In the case of Optimus, the prototype will be hard, the production will be easy. And the main thing about the prototype is the artificial intelligence, the neural nets that you need to be able to control this kind of mechanism. And they've definitely made a lot of improvements in the area of hardware with the servos and everything else. That's also impressive moving forward, but it's not quite as impressive as what it's going to be like for the brain. So once you have that brain and once that's working and functional, it'll do a lot. And I might end up looking a bit conservative in that saying, well, I know there's a low-hanging fruit. I'm pretty sure they'll get the low-hanging fruit next year. They'll be going through and we'll start seeing more and more in that. But I wonder about some of these others of inserting cables in, if they need to do that, if they'll have that mastered next year. I'm going to think that, well, it's a stretch. That'd be a stretch goal. And if they do it, I would be absolutely ecstatic that they were like way ahead of me on what my prediction would be as far as the more complex kind of task. But the low-hanging fruit, it's easy. It's very easy.
Yeah. What I love is this photo that I keep going back to, because you're telling me this was an AI day 2, which is September, which is like 9 months ago.
Yes.
Because it's now May. And this bot looks very similar to what we are seeing today. So it feels like they've already, even at September, they'd already felt like they've had a design and they've been working on it to where it is today. That's what makes me feel like, okay, it's like, yeah, it's like what we're seeing now is not just the first version of it. It's probably, 20 plus different versions, but they're all it's already solidified. You can see it, right? They already solidified you pointed out before, the joints and the actuators and the the fingers and whatever you call them. Yeah,
They,
pretty
they,
awesome.
they they pretty much decided, kinematically what they wanted to look like, and they haven't had to change it kinematically that much. But they've been improving and refining the hardware all along. So the motors are completely different. They probably improved the hand design a little bit, but the decisions of is the neck going to move or not? It's like, no, the neck is not going to move. How many degrees of freedom are they going to have in the legs? They seem to pretty much stay with that and with the torso. And then they discovered, oh, we need one more joint in the arm. And it wasn't that they changed everything all the way on down here, just like we have to add one more in the wrist. That'll make it a little bit better. So they learned from the design, they changed things a little bit. And definitely because they've gone through multiple iterations, they have an idea of what the design is going to look like. And the only thing I think they might work on a little bit more in the future might be the feet.
Yeah.
So it's still very simple foot pads that they have. The rest of it is probably pretty good, but they're probably saying it's not quite that important right now for what we want. And it would be slowing us down if we try to do it. So we're fine with what we have. And eventually I think they're going to have a different foot.
There is a company called Giant AI. Robert Scoble went in and interviewed the CEO and showed the factory. They were making a robot that was torso up. There was no need for it to have any legs or walk. And they were going to sell it to, they of course have a business model where they're going to sell it to many factories where its job is just torso up, recognize an object somewhere on the table, grabbing it and moving it somewhere else. That's all it was. And just that alone would be a massive business. Just being able to recognize one object and moving somewhere else, just sitting up, torso up. So, that I think people think that you need to have this bot that can maneuver, can recognize space. There's lots of jobs that you're pointing out that when you say low hanging fruit, that's one example where it doesn't have to move. You just move the arms, just like that table that we just saw, that video where the bot was grabbing and moving things on the table.
Yes, and in the case of an automotive factory, the parts are moving around a little bit bigger. They're not delicate, small parts. And these manufacturers that are putting together iPhones, that's a completely different kind of line. So you're not talking about big, bulky parts. You're talking things a little bit smaller, where you need the dexterity, and the workers are sitting the whole day. They're not walking around. So it would make sense if you could come up with a bot that's just a torso only, because the worker is never moving. At most, there's just swiveling in the chair, and that's it, and doing that. But the level of detail that you need is quite a bit, and you're not going to see that in the Tesla factory. You might see it in the sub-suppliers that are producing some of the parts that are coming in that they're doing the final assembly with. But within their factories, you're not going to see any operations like that. So that's why they want to have that bot with a torso, which is deployable, and deployable in the sense that it is on something that can be moved around and be mobile as it's needed. Because a lot of those tasks, I think you'd be really hard pressed to find a worker that really is stationary, is not moving around. Maybe in the seating lines a little bit, there may be some that a person might be there to do a couple little operations, but a lot of times they have to turn around, grab a part over there and bring this just out of reach. So you need a little bit of mobility. So it does make sense that they went that route. Now, if they were a company like Foxconn, they would have designed it completely differently, but because they're automotive, they see that this is the best form.
Okay. Wonderful, Scott. Love having you here. Just full of great energy, great intelligence, and always gets me more bullish. If people think I'm so bullish, but actually you're giving me actual data points to actually prove, or the more likelihood that this is here and it's coming sooner than we think. Thank you very much, Scott.
Yes.
Have you on again next time.
Okay. You're welcome, Herbert. Thank you.